Next we need to add a machining plan. So from here we click add, and amongst all of these what you need to do is choose raster finishing, so we choose that. Now a few things here that you need to append to. Step over, which is the distance from one tool pass to the next. Well, let's make that 0.8 of a millimetre. We need to ensure here that the spindle speed is 23,000. We need to check that the raster angle is 270, and for most of you this bidirectional cutting will be the choice. If you feel that perhaps your car is fragile, as in it's not very thick in the section where it connects the front to the back of the car, you may want to check with your teacher to see if we need to adjust this cut direction. So once I click on that, it's now calculating. Here you can see it's calculating the tool paths for our cutting out. Now notice here that the tool paths, all these white lines here, are cutting all the way down the front here, but in fact our car finishes here. So in order to save machining time, we'll double click on that, and what I'm going to do is I'm going to reduce this X distance down to a distance which I know is big enough to cover the car but not much more. So I change that to 220 millimeters. I'll click OK, but of course I need to recalculate the tool paths. So what I have to do is click on this calculate button, and we should get a revised tool. So here we go. So now my tool paths, the plan for the tool paths finishes here now. So we've just adjusted the boundary. If you did that and it turned out to be incorrect and you wanted to do it again, you'd simply go back to double click on raster finishing, make the change, and then recalculate. From here, what we would do is simulate what's happening. So you might want to speed this up a little. So here's our simulation of the cutting. Now it's very important that you take a picture of this. So if we go up here where this camera pictogram is, we click on that, and that will give us the opportunity to save that image. So we'll just as you can see, I've done this once before, so I'm just going to save it over the top of that one. But what you need to do is choose a name for it that makes sense. So side simulation makes sense. This is the simulation of the side machining, and you're going to attach this when you email through your machine codes so that your teacher can check that the program looks to be okay. So we'll save that, and yes, audio. So we're going to exit out of that now, and then we hit next. And the last thing we need to do is we need to, this area here is the origin, like a reference point where all the machining starts from. So what we need to do with that is to, this Y is 40 millimeters, so that is correct. The X value is 0, so that's positioned at the center of the canister hole. But this Z, what we're going to need to do is go down to minus 21, which should put us at the center of the canister hole there, because in the machine, that the center of that canister hole is our main reference point. That's the 0, 0, 0 coordinates for all of the axes. So once we've done that, we can hit, we need to make sure that Denford metric milling is selected here, and we select post-process. And as you can see, I've saved this before. I want to make sure that the title of this includes some reference to the fact that it's a side machining. So I'm going to choose side, and I'm going to go save, and yes, it's going to go over the top of that. Save. Yes.